To investigate serial correlation, our first step is to calculate correlation coefficient for those select terms. So we are using Occam's rules again. So our objective is to calculate R1, R2, R3, and R4. Then later we would like to generate a correlogram to visually demonstrate whether there are any significant correlation coefficient. So now let's switch back to Stata and demonstrate how to do that in Stata. So let's go back to Stata. Notice that here we have the data open already. The command in Stata is AC, which stands for autocorrelation, and G is the variable name. Then legs tells Stata that we are going to calculate correlation coefficient up to leg 12. Then we also would like to store the autocorrelation coefficient into a new variable. It's called AC underscore G. You can call it any other name, but I would like to call it ACG. Then this command line essentially tells Stata we would like to calculate the autocorrelation coefficient, then store it into a new variable. Now press enter. Stata will open a new window. Let me share it with you. So this is the new Windows graph. It's automatically generated by that AC command. So that shows the autocorrelation coefficients. Also the gray area, that's the confidence band. Any correlation coefficient that is beyond that band is considered to be significant at 5% level. So that's essentially a test. Now let's go back to the main window. Now we're back to Stata, and you may notice that you have this ACG, this new variable generated there already. And we can also generate another variable to calculate the z-test statistics as shown on the slide. So we generate z equals SQRT is a function of square root, so square root of n. Where can you get n? Is a variable that is stored internally. You use en to request that variable. That's number of observation. Then times AC underscore G. That's the name of the new variable that we have just generated. So we have a z there already. So you may notice that over there, the window right over there, you have both ACG and EZ. The next step is to show, okay, what's there? So list is the variable to list the content of a group of variables. So ACG is the autocorrelation coefficient, and EZ is the test statistics we generated. So in 1 to 12, we only have a 12 autocorrelation coefficient calculated. So if you press enter, that shows you over there the autocorrelation coefficients and the EZ value. So you can tell which one is above, for example, 1.96, which is the critical value. Then decide which autocorrelation coefficient is significantly above 0 or greater than 0. That's indication of autocorrelation issue. In this case, we have autocorrelation identified up to leg 2. And if we go back to, if you have your PowerPoint in front of you, you may notice those are the numbers that I calculated on my PowerPoint slide. They are marginally different simply because of a rounding error. Okay, in Stata, use maybe up to 12 significance number after decimal place, but I only use 3 in my calculation. That's why the numbers are slightly different from each other, but essentially they are the same. Okay, so this is the calculation of autocorrelation coefficient and the generation of correlogram. So this chart looks slightly different from the one with the Stata output as well, but essentially shows the same conclusion. Only the first 2 legs are significant. Our next task is to use Phillips curve dataset, and we investigate whether the residual from a linear regression model has autocorrelation problem or not. So we would like to calculate those R's up to like 5, then generates this correlogram. So now let's go back to Stata and demonstrate how to do so. We now need to use a new data set. Before doing so, we need to make sure we clear everything in the work environment so it won't cause any conflict. So if you tap clear, that will get rid of all the variables and anything in the memory. You may also want to go to the result window, just right click and choose clear result. So that part is clean too. Okay, the next step is to open the data. So if I click open, what we need now is Philips, Australia. So Philips _ AUS, that's the data. You can click open. Or alternatively, you just use, that's the Stata command line, that's shown over here, and give the software the full pass. It will open the data for you as well. And right-hand side, you may notice that we have new variables opened right there already. So that's INF and U that we're going to use. Now, if we come back over here, remember, this is just the original data set. We need to make sure it is time series data, which means we need to generate a date, then specify this time series set of data. So what we need to do is to first to generate date, and that equals to TQ is time series quarterly, starting from the first quarter of 1987. Remember to make sure the data will increase by 1 for every single observation. So if we press enter, that will generate a new variable over there. It's called date right there. But that's not enough. You have to format that variable to be a quarterly time series data. So the format is time series quarterly, and the variable you would like to format is date. Press enter, is formatted. So we need to use TSSET date. That tells that we are going to use date as the variable to index the whole data set. So that's the index, time index. So Stata said, okay, I recognize that its time variable is date. That's from the first quarter of 1987 to the third quarter of 2009, and the increment by 1 quarter. The gap, the step is quarter. Okay, now the data is ready for analysis. What we need to do is to, so for example, if you would like to have a look at the trend over time, you can use TS line. So you have INF that will give you this window. So you will see, okay, over the time, this is how inflation rate changes over time in Australia. So similarly, you can use TS line to generate a line chart for you as well. We will leave it to you. So the next step is to estimate a linear regression model. You can use either regress or just REG. That's the same thing. For the first 3 letters is sort of the shorthand of regress. So REG, the independent variable is the difference of U, and the dependent variable is inflation. So that's the linear regression model we want to estimate. Remember, we would like to check whether the residual has an autocorrelation problem or not, or in other words, whether it violates one of those important assumptions behind OLS. So the first thing we need to do is to retrieve the residual series from the memory. It's in the memory, but you have to store it in a variable and put in your data set so we can perform analysis later. The command is predict, is a Stata command that can generate some new variable based on a regression estimate. So we predict E hat, and essentially we generate a new variable. It's called E hat. And what is put in E hat in the new variable is the residual from the regression model. So RES tells Stata, I want a residual from the regression model you have just estimated, and put it into a new variable, and it's called E hat, and put it in my variable list. Okay, so if you press enter, you may notice that you have a new variable right hand side over there, E hat, that's residual. Now we can use this residual to perform a test. So remember, we use AC autocorrelation command before to generate those correlation coefficient. We can use it again, but now your variable now is E hat, not G anymore. So E hat and lags, once again, we would like to see more. So let's have 12. And we also store the result into a variable is called RK. So press enter. First of all, as Stata will show you the correlogram right over there. And you may notice, oh, the first four, they are quite large, well above the confidence interval. And let's go back to have a look at the specific value of this series. So now, let's switch back to Stata. Now we know the new variable RK is right there. So you check the window variable list there, RK. So what's in there? Use list RK and have a look at the first 5 observations. So it's list over there from 0.548 something all the way to 0.339. And those are the values that are calculated on my PowerPoint slide. Once again, the numbers are slightly different simply because of rounding errors. We have those RKs there already. We can also perform an LM test, which is a joint test of correlations at more than one lag. So it's more flexible, so has a wide application. What we want to do is to check whether the error term of this regression model has autocorrelation issue up to a lag P, for example. So from this regression model, we will check whether the test statistic, which is right over there, is the R square from this regression model times the number of observations. It follows a chi-square distribution. And if we apply it to the Phillips curve problem, this is the test equation we need to estimate. That's basically we regress the independent variable, which is the difference unemployment rate, and lag terms of residual on the self. Then we check whether the test statistics is significant or not. Because of the differencing, we will have some missing value. So for example, if you have the first difference, you will lose one observation. Lagged variable also will have these consequences of missing variable. So there are 2 approaches. One is just delete the variables with the observations with the missing value. Another one is replace the missing value with a 0. We will demonstrate the 2 method using Stata. So let's switch back to Stata. Recall that we have already estimated this linear regression model by using this command right there. And we have the regression output given in the result window. We store the residual into this new variable, which is called E hat already. And we're ready to estimate this regression model. The command line is reg E hat. That's our residual. That equals to du, that's our independent variable. And if we want to estimate the regression model or perform the test by using just one lag only, we will have L dot E hat. So that's with one lag. And if you do so, press enter. You may notice that the total degree freedom is 88 right there. And if you go up, the total degree freedom over there is 89. So there is a difference of 1 observation between these 2 sets of regression. This is because by taking the lag term of E hat, we lose 1 observation. The first observation has a missing value for L E hat. And without doing anything, the software will skip any observation with the missing value. So that's the first method already. And we have this regression output, and R square over there is 0.3102. So what we can calculate the test statistic by using this command line. So either use display or simply just input di. So di and display is the same thing. It will show you the content of a certain variable. So we display and use quotation mark to tell Stata what you want to display on the screen. So anything within this set of quotation marks will display as it. So observation equals space, put into a set of quotation marks. So that's what going to be displayed. And then space, en, so that's the number of observations. Then use another set of quotation marks, space, and tr2 equals space, quotation marks. So those are the tests to be displayed, and followed by the variable, the value of the variable or the calculation you want to display. Okay, en gives us the number of observations, and er2 gives us the value of r squared, which is 0.3102. So those are the values stored in the memory. We just use en and er2 to request them. And anything that I put in the brackets, the sets of brackets, sets of quotation marks will be displayed as it. So press enter. This line is the result. That's the output of that command. So observations equal, that's from this set of quotation marks. 89 is the value of en, and tr2 equals, that's within this set of quotation marks, and 27.608808, that's the value of this expression. So en times er2, it gives you the statistics. Now you can compare it with the value on my PowerPoint slide. They are quite close to each other. The difference is only due to rounding error. Now we're ready to perform this LM test by using the second method. Specifically, we would like to replace that missing value with 0. Before doing so, let's have a look at the data, just to have some idea about what we're going to do next. So let me share the screen with you first. So this is a data editor window, and you may notice that we have an e hat here, and the first observation is 0. So what we would like to do is to replace this value, this missing value, with 0. Now let's switch back to Stata. The command is, of course, is replace. So we would like to replace the value of some observation. So replace the variable that we would like to make some changes is e hat, and we replace this value with 0, but for the first observation only. So if you do not input in1, if you omit this, that's going to replace e hat with 0 throughout. But if you specify in1, that will only work for the first observation. So if we press enter, and let's switch back to the data window. It's not yes, over there. Remember, it's a 0, it's a dot or missing value previously. Now this change should be 0. So if it is not a missing value, the number of observations will be different in our next step. So let's go back to Stata. Now remember, we have the value for the first observations changed for e hat. Then we need to rerun the regression model, because now we are going to use more observations, not 89 instead of, that should be 90. Okay, and the degree of freedom should be 89 after we run it. So what we need to do is to rerun this regression model. So e hat is a dependent variable, and du is the independent variable. We also would like to have the lag term of e hat in our regression model. So press enter. Now you may notice that the number of observation right now is 89. 89 plus 1, that's 90, not 89 as before. So now let's use the same command line over there. You can just go back, copy and paste. So this is the second method. We didn't omit the first observation. Instead, we replaced the missing value with 0, and we rerun the regression model, re-estimate the test statistics. Now, we notice that your test statistics are different. The total observation is 90 now, not 89. And the test statistics is 27.59, which is quite close to the value that I used on my PowerPoint slide. So this is just a LM test up to lag 1. On my PowerPoint slides, I also perform another test with another LM test, but it's up to lag 4. What we need to do now, if we want to perform an LM test up to lag 4, the residual series will be different because we are going to have a different regression model, a test equation. Therefore, it's important for us to drop the old variable that's E hat residual, then generate a new one. So first thing we need to do is to drop E hat. So go to the command window, type drop E hat, and keep your eye on the variable list over there. Once you press enter, E hat will be removed. So the workplace is clean. Now we need to re-estimate the regression model. So REGINF DU. So that's the regression model re-estimated, and then predict E hat RES, that's residual. So it's a new variable generated. Then we regress E hat on DU. This time we consider lagged terms of E hat up to lag 4. So that's what that regression command line does. Press enter, that will give you this new regression output, and you may notice that we have 4 lag terms of E hat included in this regression model. So this is just our test equation. We would like to calculate, okay, what the test statistics are. And the first method will simply just omit the variables with missing value. So the first thing we need to do is to display that's what we did before, the number of observations, and that's the test we want to display. And the value we would like to calculate is En times the R square of this regression. So that's 33,385 something. So this is the first method. We omit the number of observation. That's 86. Oh, I forgot. Look, I forgot to put a space there. So this is why it's kind of crowded over there. What we need to do is to put the space over there. If you want to have more, that's even okay. It is even better. So that's the difference. Our objective now is to use 90 observations instead of 86, which means we would like to use the information that is stored in the first 4 observations. So before we start manipulating the data, let's have a look at the data that we have. Okay, now let me switch to the data window. Here's the data set, and we are going to use E hat in our test. You may notice that the first observation is missing already. This is why when we perform an analysis, the number of observation is 90 if we have a lagged 1 LM test. If we would like to test LM4, by default, there will be 86 variables observations used as indicating our output, because the first 4 will be missing due to the effect of lagging. Okay, now let's go back to Stata window. Let me show you how to generate those variables so that we can use 90 observations. So first thing that we need to do is to add 3 observations. So we use set OBS 94. So remember, we have 91 observations in total, but the first one's missing. So in total, we have 90 valid observations. We want to use all of them. To do that, we set observation to be 94. Now, if we go back to the data window, here, what happened is at the bottom of this data file, we have 3 observations added, but all of them have missing value. We don't care about it for 3 because we don't use them, but the last one, they are important. Okay, so next step is to sort the data and move those missing variables to the end. So we use gsort minus date to make sure everything is in order. Okay, so if we go back to the data window, you may notice that, okay, we have the observations sorted in descending order by date, and all the missing values are at the bottom. And the command line that we used are over here. So that's gsort minus date, that means descending order. The next thing to do is to replace all of those missing values to be, the date missing value to be the corresponding date. So what we need to do is to use this command line, replace date equals date So essentially that tells us, okay, I would like you to have a look at the date column. If the value is missing, replace it with the value of date, but make sure it's in descending order and the step value is 1/4. So this is what the command line is asking Stata to do. So once you submit that command line, 3 real changes have made. Now let's go back to the data set to see what kind of changes have been made. Okay, so go back to the data window, go down to the bottom. Remember, we have a 3 missing value back there before, but now it was replaced with the corresponding quarter, but in descending order. That's what the last command line did. Next, we would like to replace this 4 columns, 4 rows. Okay, over there, these 4 rows, those missing value to be 0. Once we do that, we will make sure after we take 4 lags, after we include 4 lags in our regression model, we still have 90 observations, which means everything starting from this line, 90, those values can be used hat. Otherwise, there will be we will have some missing value. Okay, so you put 0 here, you can use those values to calculate the lagged value. That's the idea. So we need to put 0 here. Without that 0 value, you won't be able to calculate the first 4 lag terms. Okay, now let's go back to the command window. Now we're back to the command window. Use replace again to replace hat with 0 only when have a missing value. So when hat is missing, we replace it with 0. So this is what that command line does. So 4 real change made. Let's go to the data window to see what kind of changes have been made. So the data window, go down to the bottom. You may notice that those 4 missing values are replaced with 0. Okay, the next task is to rearrange the data to be in ascending order. So we use sort date. So the data are sorted accordingly. So if you go back to the data window, you may notice, oh, here, it's sorted by date in ascending order. and E hat, those observations are replaced with 0. With those zeros in place, we will be able to have 90 observations when we include 4 legs in our regression analysis. Okay, now let's go back to the command window. So we need to use this regression model. So that's regression, reg or regress. E hat is a dependent variable, and du is the independent variable. We also would like to include up to 4 legs of E hat in the regression model. So that's the result. And you may notice that the degree of freedom is 89, which means we have 90 observations in our analysis. Now, basically, we can go back to the result window, just copy and paste the regression that we had before, like this one. And we can also copy and paste the command line that we used to request the statistics. This is based on method 1. So we delete all the observations with missing variables, and we have 86 observations in our test. Now, after replacing those missing variables, creating those variable observations for the leg terms, now in total we have 90 observations in the test, and the test statistics are different from the one that we had before. But those are values that are quite close to what's included in my PowerPoint slides. Up to this point, you may notice that the command lines that we used so far for the LM tests are rather tedious. As a matter of fact, Stata is a proper statistical analysis software, so it does have a built-in command that can perform LM tests automatically without going through the trouble of generating values for those variables with missing values. So the command is bgodfrey. So what we need to do is to use this command line, that's estat, and we request the LM test as follows: bgodfrey, that stands for the test we're requesting. Then we want to test up to leg 1. That gives us the chi-square test statistics, which is 27.592. That is quite close to the test statistics that we used before by using method 2. So for this BGLM test, that's a built-in one. By default, the system will replace missing value with 0, then perform test for us. Similarly, if you extend the leg length to be 4, you will have the test statistics reported straight away. That's 36.67. Due to some rounding errors, it's slightly different from the one that we generated manually in previous steps, but the conclusion will be the same. You're going to reject and not have the hypothesis based on this test. So this is a more efficient way of performing LM test in Stata.